A team of researchers, including those from Imperial College London, has successfully measured previously inaccessible parts of the Martian atmosphere using redesigned equipment. These areas, which can obstruct radio signals if not properly accounted for, are critical for future Mars settlement missions. The results from the first 83 measurements, analysed by Imperial researchers and their European Space Agency ESA colleagues across Europe, were published today in the journal Radioscience. To achieve this, the ExoMars Trace Gas Orbiter TGO collaborated with another ESA spacecraft orbiting Mars, the Mars Express MEX. The two spacecraft maintained a radio link, allowing radio waves to penetrate deeper layers of Mars' atmosphere as they passed behind the planet. Changes in the refraction of the atmosphere, how it bends radio waves, cause small but detectable changes in the radio frequencies received by the spacecraft. By analysing these changes, scientists can determine the density of the lower atmosphere and the electron density in the ionosphere, the charged upper layer of the atmosphere. This technique is called mutual radio occultation. Jacob Perrott, a PhD student in the Department of Physics at Imperial and the lead author of the study, stated, "The systems on MEX and TGO were not initially designed for this. The radio antennas we used were intended for communication between orbiters and rovers on the planet's surface. We had to reprogram them to perform this new science on board." This innovative technique of mutual radio occultation between two orbiting spacecraft proves to be an economical way of extracting more scientific value from existing equipment, potentially changing the game for future missions. Previously, radio occultation was performed using a radio link from a Mars orbiter to large ground stations on Earth. The radio signal from the orbiter was tracked as the spacecraft set behind Mars, meaning the signal passed through the planet's atmospheric layers. Varsale and metanacing to orbiting spacecraft to take this measurement is already a common method for investigating Earth's atmosphere. Thousands of such measurements occur between global navigation satellites, and the data they provide is used for atmospheric monitoring and weather forecasting. However, this method had only been used on Mars 3 times before in a hardware demonstration by NASA in 2007. The new use of 2 ESA spacecraft demonstrates the first routine application of this technique to another planet. Having proven its feasibility, the scientists and engineers behind the study are now exploring how to extend the use of this technique in future Mars missions. Dr. Colin Wilson, ExoMars Trace Gas Orbiter and Mars Express project scientist at ESA and a co-author of the study, commented, "ESA has now demonstrated the feasibility of this technique, which could transform Mars science in the future. There are currently 7 spacecraft orbiting Mars. As the number of spacecraft increases, as expected in the coming years, the number of radio occultation opportunities will also rapidly increase. Thus, this technique will become an increasingly important tool for studying Mars. Mutual radio occultation allows for more measurements and the investigation of new regions of the atmosphere. Traditional radio occultation measurements on Mars involve a radio link to a ground station on Earth, meaning the measurement location is fixed relative to Earth's slow movement. This makes capturing global changes on Mars difficult, as researchers often look at the same spots. Additionally, this method only samples near sunrise and sunset due to Earth's proximity to the Sun, limiting our view of Mars' atmosphere. Moreover, traditional radio occultation suffers from occultation seasons where measurements are only possible for a few months each year due to the spacecraft's orbit. For example, Mars Express could only perform radio occultation for 2 months in 2022. Mutual radio occultation overcomes these issues, allowing researchers to explore the full depth of Mars' ionosphere around noon and midnight for the first time.